In today's math lesson, we're going to discuss the domain and range of exponential functions given equations. As we saw in the previous lesson, the domain of an exponential function are the x values, and for all exponential functions that we are given, we know that they are going to have a domain of all real numbers. So that's a really easy problem to answer. For the range, we know that we're looking for the y values. Our star player to tell us where our range is going to go is a. If our a term, the number that's all the way out in front of our base, is a positive, then our curve is going to move upward. And it could move upward above our asymptote from either direction, which means that as a result, we are going to use the greater than sign. If a is negative, then our graph is going to be moving downward from either direction, which means that we are going to be below the asymptote and thus using a less than symbol. Now the big question is, a greater than or less than what number? It's our number c. So our range is always going to be y greater than or less than c, depending on which direction our graph is going to be traveling. Because our asymptote is whatever c is, y equals c. That's our asymptote. So if there is no number showing here at the end of an equation, then you can say that y is greater than or less than 0, because no number implies that there is nothing. And what number is nothing? 0. So something new just to keep in mind. If you are asked to determine what is the asymptote for any given equation for an exponential function, then you can quickly say that it will be y equals c. That is your asymptote because that is where your graph bottoms out. And again, if there is nothing here at the end of your exponential function equation, then it would be y equals 0. Now finally, if you find these equations just too stressful to deal with, you can always graph them on Desmos, like we did in the previous lesson, and then you can have a pictorial version of what is happening for each of these equations, and then you will be able to determine both the domain and the range. In example 1, we are asked to determine the domain of the given exponential function where y is equal 2 to the x power. We saw in our introduction that the domain is still the x values for our given function, and we know that from our introduction that the domain is always all real numbers for any given exponential function, especially if you are given a whole equation. So it doesn't even matter what the equation was for this exponential, we automatically know it is all real numbers. And there you go. In example 2, we are asked to determine the range for our exponential function where y is equal to 5 to the x power. Since the range is asking us to discuss the y values for the given exponential function, we return to our parent function of a times b to the x power plus c. So we saw in the introduction that if a is a positive number, then we will be moving upward. So our equation is 5 to the x power. So we would say, all right, so what's in front of this 5? It's a positive 1. Since a is a positive number, then we know our graph is going to be pointing upward. And where things are pointing upward, we use a greater than symbol. So that takes care of B and D, as they both have greater than or equal to symbols. And we don't use the equal to symbol. Now our C, that needs to be dealt with. In our equation, we have nothing at the end of it in the C position. So what could we show as being there? Oh, a 0. So that is where our graph is going to bottom out. That is where the asymptote could be. So we can show here that our range is just greater than 0, as there is no number in the C position. And there you go. In example 3, we are again asked to find the range of this exponential function where y is equal to 1/4 times 3 to the x power. As we're asked to look at the range and we know that it is the y values, we again look at our parent function of y equals a times b to the x power plus c. So here it all is. And our specific equation with 1/4 times 3 to the x power, we know that our a is equal to 1/4. And since 1/4 is a positive number, that means our exponential function is going to travel moving upward. So we are going to have a greater than symbol, and we know from our asymptotes that we are not allowed to have a greater than or equal to, which takes care of answer option B and D. Now our C does not show anything here, which means that we would have a plus 0. That would tell us where our curve is going to bottom out, and it is going to have a lowest point of access. Its bottom of the range is going to be at 0. So we find that our answer is again A, where our range is y is greater than 0 because c is equal to 0. And there you go. In example 4, we are again asked to look at the domain of the given exponential function, where y is equal to 7 to the x plus 6 power. So while we know we're looking for the domain, and the domain is the x values that get used in the graph, this equation looks a little bit different only because there's more than an x up in the exponent. There's an x plus 6 up there. Does that change the rules of engagement? No, not at all. It just means that our curve has been slid over across the x-axis in its curve location, I guess. But it doesn't change how far that it actually travels from left to right. So our domain is still all real numbers, even though we have an exponent that's more than just an x up there. So there you go. In our fifth and final example, we are asked to find the range of the given exponential function, where y is equal to negative 1/6 times 9 to the x power plus 3. There's a lot going on in this function, so let's explore it carefully. So we know that the range is asking for the y values, and we're going to again look at our parent function where y equals a times b to the x power plus c. And with our specific example, we have a negative 1/6 in the a location. We have a 9 in the b location, and we have a plus 3 in the c location. So let's see what this does. Since our a term is negative, that means that our graph is going to be pointing downward. And when things are pointing downward, that means that we're going to use a less than symbol. With that being said, we know that we're not going to use answer B or answer C because they both have greater than symbols. All right, so now we have to address the C. So our asymptote is happening where C is located. And for us, our C is equal to 3. This tells us where we're going to bottom out or top out the curve. So our asymptote is at y equals 3, and therefore we can say that our range is going to be less than 3. So that tells us that it cannot be A, as we have a 0 there, and it must be D. So our range for this problem will be y is less than 3. And there you go.